I hope that you were able to download your geometry notebook. We're going to use this notebook throughout the school year, and we're just going to keep adding slides to it. So when I click through this notebook, the first thing I put in here is your syllabus. So you have it. You have your Mind Info, your Google Classroom code, all the expectations for class, all my information if you need to reach me, and things that we'll cover in the grading policies. So let's start with Unit 1. Unit 1 is going to be about the geometry basics. So I put all your vocabulary just in case you want to go look it up for the first 3 weeks. Today we're going to start with Wednesday the 26th. So here's your due now. I'll expect you to do this and then go ahead and submit your answers where it says submit your answers here. The first things about geometry is that you have to understand is we have these things called undefined terms. We have 3 undefined terms in what we call Euclidean geometry. Euclidean geometry is the study of flat space, and it was created by this old guy named Euclid. So point, line, and plane look differently depending on what type of geometry you're talking about. And in Euclidean geometry, they have a specific definition, but they're still considered undefined because that definition changes depending on what type of geometry you're looking for. So the definition of a point is it's an exact location in space with an indefinite shape and size. A point looks like this, and it's named by a capital letter. So we call this point X or X. Notice that X has to be capital. Well, a line is an object with no thickness that extends infinitely in 2 directions. What's important about a line is that it's named by 2 points or a fancy lowercase script letter. The other thing about this line is it does extend infinitely in 2 directions. So do you notice how it has arrows on either end? We can call this line AB, or we can call this line BA, or we can call it line fancy lowercase m. A plane is a flat surface that continues infinitely in all directions. So this plane is named by 3 non-collinear points. So I can call this plane ABC. I can call this plane BCA. Or I can call this plane K by that fancy uppercase script letter. A line segment is just the piece or part of a line that has 2 endpoints. So we can call this line segment AB, or we can call this line segment BA. Look at how the symbol over the top of AB changes when you're calling it a segment. A ray is just another part of a line, but it has 1 endpoint and it goes infinitely in another direction. So here we have ray AB. We cannot call this ray BA. The reason why it has to be called ray AB is because it starts at point A and it goes towards point B. Notice over the top of this, the symbol changes because it's a ray. Okay, so opposite rays are rays that go in opposite directions. They share a common endpoint. So the common endpoint that these 2 rays would share is X. So we would call the first ray, ray XY, and we would call the second ray, ray XZ. These are called opposite rays. Collinear are points that lie in the same line. If the points do not lie in the same line, then we call these points non-collinear. So here's an example of collinear points. A, P, Q, and B are all collinear. Coplanar are points that lie in the same plane. If the points are not on the same plane, then we call these points non-coplanar. If you look, A, B, and C fall on the same flat surface, so they're called coplanar. A midpoint is the point on a segment exactly halfway between the endpoints of the segment. So here, WX is my segment, Y is considered the midpoint. If you notice on the picture, it has those little hash marks. That means that line segment WY is congruent to line segment YX. A segment bisector is the same exact thing as a midpoint, except for instead of it just being a point, it's a segment line or plane that intersects a segment at the segment's midpoint. So as you can see, we have segment PQ here. And if I need to make this bigger, I can. We have segment PQ here, and there's that line segment that bisects it. It goes through the middle at F. And you still see the tick marks or the hash marks that show you that PF, line segment PF, is congruent to line segment FQ. We also have this thing called a perpendicular bisector. It's a segment bisector, except for it goes to the midpoint at a 90-degree angle. If you can see the difference between the two pictures. You can also see on this perpendicular bisector the two tick marks or the hash marks, which shows you that those two line segments are congruent. Okay, intersecting lines and planes. Two lines always intersect at a point. Two planes always intersect at a line. And a line intersects a plane at a point.